Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, in this problem, we're told we have two particles that go through a mass spectrometer, enter a magnetic field, and travel in a circular path. We have x1, which is a +1 ion, and we have x2, which is a +2 ion. We're told that the magnetic field, the voltage, and we have that we're told the magnetic field and the voltage are the same in both cases. So B and V are the same, and we're told that the mass is so small that it is non-detectable. So M is also going to be the same in both cases. So these three terms are all constants. And we want to find the ratio of R1 to R2. Okay, so now we need an equation that relates all of these variables, or in this case, constants. And we do have one. We have an equation that states that the mass, for a spectrometer, the mass of the particle is equal to the charge times the radius squared divided by 2 times the voltage times the magnetic field squared. Okay, there's our equation. We have everything we need. So now we need to apply our knowledge of physics to solve this problem. So we know that B, V, and M are all constants in both cases. That being the case, I'm going to rearrange this equation so that those constants are all on one side, which, those being constants, the only things that are not are Q and R. So we can move all this over to that side and leave the Q and R on this side. And I'm going to reverse it so we have the Q and R on our left-hand side. So we have R squared times Q, or Q times R squared. It doesn't matter what order you write those in. That is a rule for multiplication. So we have R times Q, R squared times Q, is equal to, we have the mass, times 2V, we'll write the constant outside, 2V divided by V squared. And we also have we get Q on this side. Okay. So this is now in the form where we have all the constants on one side and all the variables on the other side. And this is the same for both cases, which means that both cases have to be equal to each other. If we take a look at just this part, these are all constants. So we could equivalently write this as just one letter. We could just call it C for a constant. And then we have the same equation if we say that this is the first scenario, 1 M1 Q1 R1. The same case happens for the second particle, R2, or for X2. And it'll be equal to the same C. So we have R1 Q1 is equal to C, and we'd have R2 squared Q2 is equal to the same C. But C is this, and it's equal to that, so we could also rewrite this equation as R2Q, forgot the sub Q, or the sub 2, R2Q2 is equal to R1Q1. Okay, this is starting to look promising. All we have to do now is get rid of the Q's. So we have these two ions. What does that mean? So we're told that these are positive ions, which means for a elementary particle to become an ion, it has to lose an electron to give it a positive charge, which means the first one here, x1, has lost one electron to give it the +1 charge. The second particle has lost 2 electrons to give it the +2 charge. So we have Q1 has only lost 1 electron, so Q1 is equal to E, the charge of a electron, or a we can say it's so usually negative E is for an electron, or you can write it as a plus for a proton, which in this case it's positive, which would be a proton. Electrons and protons have the same charge. So we have Q1 is equal to E, and we have Q1, because it has lost 2 electrons, it is equal to plus 2E for its charge. So that means we have an E on both sides. So we can divide both sides by E. It'll cancel that E. And we'll still have this 2. This 2 here is probably the most important part of this equation. That's what we have left. We have to keep that. So now this would become so we have 2, that 2 that's left over, times r squared. This is r2 is equal to r1 squared. Now we want the ratio of r1 to r2. So if we divide r1, I'm going to flip the equation again to get what we want on the left-hand side. So if we divide both sides by r2, we'll just be left with the 2 on that side. So divide r1 by r2. These are both still squared. And we just have that 2 left on that side. So now we need to take the square root to get rid of this square, which gives us our ratio. We have r1 divided by r2 is equal to the square root of 2. And that's your answer. So what does this tell us? So the square root of 2 is approximately 1.4. That's a number that is bigger than 1. That means if we divide r1 by r2, it's greater than 1, which means r1 is bigger than r2. So the weaker charge here is going to have a larger radius than the stronger charge. And that makes sense. The stronger charge is going to pull it in tighter, have a smaller radius. And there you have it.